California, America's breadbasket, crown jewel of an empire, a land of industry, progress, a peaceful place. But here lurks a noisy threat. The lifeblood of our state, its mighty rivers, can turn against it in an instant. Watch how the Casumnes River grows to fill its floodplain in only a day. But how will we know when the swollen Casumnes might turn its might against man and his works? How can the fine cities of Rancho Murrieta, Wilton, and Elk Grove, as well as the numerous small farming communities along the Casumnes, protect themselves? Like most perils of the modern age, we can solve ours with science. Let us go to the Ferrara Instructional Films blackboard and see how we can solve this quandary. The first step to protecting the Casumnes River is to find data. We found over 100 years of data points from the United States Geologic Service. We'll remove the data that doesn't make any sense or isn't useful. These values are either formatted wrong or missing data we need to continue. Great! Now our data is ready to use. We'll sort our years by peak discharge, with the wettest year on top. Then we assign them a rank. The year with the highest discharge is ranked 1, the second highest 2, and so on. Now we'll solve for the recurrence interval. We'll use the Weibull method to do that. In this formula, T is the recurrence interval, N is the number of ranks in the dataset, and M is the rank of the water year. Using this formula, we can find out all of our intervals. Easy, right? Now we'll make a graph. With just a little bit of elbow grease, we'll see a great curve. Now we have to remake it in a logarithmic scale. If this were the distant future, or something, we could do that by selecting the axis and switching it out. But we'll do it by hand. Making graphs is fun, right? No? Well, me neither. Anyway, we replot the graph on a logarithmic scale and add a trend line. Once we know the trend our discharge follows, we can use it to tell the future. Let's forecast out a 200-year flood. What a monster that would be! First, we take our formula from the trend line we made. Then we plug in 200 for x, because the recurrence interval is on our x-axis. Then we solve for y. We get about 73,000 cubic feet per second. That's a lot of water. We could also do a similar plot for gauge height to see how high the river would flood, assuming the banks of the river were vertical, that is. If we extend that to the 200-year flood, we'd see 21 feet of water. Now that we've predicted our floods, we can plan for them. American engineers and laborers can strike back and control our state's temperamental stream. Our dams and levees can be made to withstand even the most powerful floods, within reason, of course. With the diligence our nation loves, we can ensure that no floods like this can ever happen again. It's engineering, science, technology, and of course, solid infrastructure that makes this country so great and will keep it great into the future.